Our goal is to balance this redox reaction in acid. And before we get into the steps, let's talk about the fact that this is a redox reaction by assigning some oxidation states. And so we start over here with the dichromate anion, and we know that oxygen has an oxidation state of -2. We have 7 oxygens, so -2 times 7 gives me -14 as our total here. We know that the total for the entire anion has to equal -2, which is the charge on the dichromate anion. Therefore, we must have plus 12 for all of our chromiums here. So plus 12 and minus 14 give us -2. Since we have 2 chromiums, each one must be plus 6. And so that's the oxidation state for chromium here. We go over here to the chloride anion, right? So the charge is -1, so our oxidation state is -1. Chromium ion over here, so plus 3. And then finally chlorine over here, so oxidation state of 0. So if we look at chlorine, chlorine went from an oxidation state of -1 to an oxidation state of 0. That's an increase in the oxidation state. Therefore, chlorine was oxidized here. If we look at chromium, chromium went from plus 6 to plus 3. That's a decrease in the oxidation state, or a reduction in the oxidation state. Therefore, chromium was reduced. And so this is a redox reaction because something is oxidized and something is reduced. In terms of balancing it, our first step is to write the different half reactions. And so we're going to break those into an oxidation half reaction and a reduction half reaction. So let's go ahead and get some space down here. And let's go ahead and write our half reactions. And so we had the chloride anion, right, going to chlorine like that. And we said that this was our oxidation half reaction. So I'll put that way over here on the right. So that's our oxidation. Our reduction half reaction involved chromium, right? So we had the chromate anion here, so Cr2O7 2 minus, right, going to chromium 3 plus like that. So this is our reduction half reaction. So that's step 1. Write the different half reactions. Step 2, balance the atoms other than oxygen and hydrogen. And so if we look at our first half reaction, right, chlorine, we have 1 chlorine on the left and 2 chlorines on the right. So we need to balance it by putting a 2 over here on the left like that. We go down here to the reduction half reaction, and we have 2 chromiums on the left and only 1 on the right. And so we have to put a 2 right here to balance it. So step 2 is done. Step 3, balance the oxygens by adding water. So if I look at my oxidation half reaction, right, there are no oxygens, so I don't need to worry about doing anything to this half reaction at the moment. I go down to the reduction half reaction, and I do have to balance my oxygens, right? So if I go over here, and I can see that I have 7 oxygens on the left side and none on the right. And so I need to do that by adding water. And since I have 7 oxygens on the left, I need 7 oxygens on the right. So I'm going to go ahead and add 7 water molecules, and that now gives me 7 oxygens on the right of my half reaction. So that's this step, step 3 right here. Step 4, balance the hydrogens by adding some protons. So let me go ahead and I'll use red for this. So step 4, balance the hydrogens by adding protons here. Once again, the oxidation half reaction, we don't have to do anything because we don't have to balance oxygen or hydrogen here. But again, we go down to our reduction half reaction, and we have the oxygens balanced by adding water. But by adding water, now we have some hydrogens on the right side. So we can see we have a total of 14 hydrogens on the right side. So 7 times 2, and so we're going to balance that by adding protons, and so we need to add protons to the left side of our half reaction, so we need to add 14. So 7 times 2 is 14, so we go ahead and add 14 H plus to the left side of our half reaction. So step 4 is done. Step 5, balance the charges by adding electrons. So let's get some more space here first of all. Okay, so we're going to balance the charges by adding electrons. So first let's analyze what kinds of charges that we have here. So we'll start with the top oxidation half reaction. So we have the chloride anion, right, which is a -1 charge, and we have 2 of them. Right, so we have 2 negative charges. So there's 2 negative charges. Notice these are not oxidation states, so that's what gets people confused sometimes. These are charges. Over here on the right, we have no charges, right? So that's a neutral chlorine molecule here. So we have 2 negative charges on the left and 0 for a charge on the right. So we need to figure out how to balance those charges by adding electrons. And so it makes sense that we would have to add 2 electrons to the right over here, because that now gives us a total charge of -2 on the right. So that's one way to think about it, just getting these numbers equal here, this -2 right here and this -2. Another way to do it would be, of course, you know the electrons have to go on the right side because this is the oxidation half reaction. And one of the ways to remember that, right, Leo the lion, right, so loss of electrons is oxidation. And so if you're losing electrons, they must go on the product side of your half reaction. And so our top half reaction, our oxidation half reaction, is now balanced. Let's go down to our reduction half reaction, right? So Leo the lion goes grr, so gain of electrons is reduction. So we already know we're going to have to add electrons to the reactant side of this half reaction. But let's see if we can figure out how many electrons we're going to need to use. So we have 14 positive charges from the protons, and then we have 2 negative charges from the dichromate anion here. So we have 14 positive charges and 2 negative charges, which gives us a total of 12 positive charges on the left side. On the right side, we have a chromium ion, right? So this is a charge of 3 plus, and I have 2 of them. So 2 times +3 gives me +6. So I have +6 on the right side of my half reaction. So I have +12 on the left, +6 on the right. I need to add some electrons to balance out that charge. I already know I'm going to add them to the reactant side, right? I know that from Leo the line goes grr. Or I can just think about the fact that if I have 12 positive charges, I would need to add 6 negative charges to get me to a total charge of +6. So I need to add 6 electrons to the left side over here. So I'm going to go +6 electrons like that. And now we have the charges balanced, and so this step is done. So step 5 is done. We move on to step 6. So make the number of electrons equal. So what does that mean? Well, let's focus in here on the electrons that we just added to our half reactions, right? So if I go back up to here, all right, we added 2 electrons to the oxidation half reaction, and we had 6 for the reduction half reaction. But we know that that number has to be the exact same number because the electrons that are lost, right, from our oxidation half reaction are the exact same electrons that are gained in our reduction half reaction. So that is why we have to make these electrons equal in terms of the number. And so the way to do that would, of course, be to multiply my first half reaction by 3, because if I multiply my first half reaction by 3, that would give me a total of 6 electrons, which is what we're looking for, making the number of electrons equal. So let's go ahead and do that. I'm going to rewrite our first half reaction. I'm going to multiply everything in our half reaction through by 3, so everything in parentheses. So if I take 3 and multiply that by 2 chloride anions, I would of course get 6, right? So we have 6 chloride anions like that. And then the 3 would go in front of the chlorine, so I have 3Cl2, and then 3 times 2 electrons, right, gives me 6 electrons like that. Okay, let's go ahead and rewrite our reduction half reaction because we have a lot of stuff going on here. So I'm just going to rewrite exactly what we have. 6 electrons plus 14 protons. 14 protons here plus the dichromate anion like that. Right, and then I have two chromium ions and 7 waters. Okay, so now I have my 2 half reactions. I've made the number of electrons equal, and we're ready for the last step. We just take our 2 half reactions and we're going to add them back together, and that's going to give us our overall balanced redox reaction. So let's go ahead and we'll go ahead and say we did this, and let's go ahead and get some more room here so we can add those 2 half reactions. All right, so all I'm going to do is just take everything on the reactant side, right? Take everything on the reactant side here, right, and add that together. So let's go ahead and just rewrite everything on our reactant side. So we have 6 Cl minus, right, and then 6 electrons, 14 protons, right? We have the dichromate anion here. And then I'm going to take everything on my product side, right? So I'm going to take all of this stuff right here, right, and put that on my product side. So I have 3Cl2 plus 6 electrons, right, plus 2 chromium ions plus 7 water molecules, like that. And so now it's just a little bit easier, I find, for students to see that your electrons are going to cancel, right? You have these 6 electrons on the reactant side, you have these 6 electrons on the product side, so you can go ahead and take those out. And we're left with our final answer, right? So you could go ahead and rewrite it if you want to make it look better. We have 6 Cl minus plus 14 H plus Cr2O72 minus yields 3Cl2 plus 2Cr3 plus 7H2O. And this should be our final answer. So I always like to box my final answer, so it just makes it easier for your instructor to grade. And the nice thing about redox reactions is when you're finished, you can always check yourself, because you know that you need to balance both the atoms and the charge. So let's go ahead and check that real fast. Let's first start with chlorine, right? So we have 6 chlorines on the left, and then over here on the right we have 3 times 2, which is 6. So chlorine's balanced. Hydrogen, we have 14 on the left, and then 7 times 2 gives us 14 on the right. The chromiums, we have 2 on the left, and then over here we have 2 on the right. Oxygens, 7 oxygens on the left, and then over here, right, this 7 applies to this oxygen, and so the atoms are balanced properly. Let's next check charge, because you have to have the correct charge. We have 6 negatives, right? So 6 negative charges. I'm going to put minus 6 here. And then I have 14 positives, right? So I have positive 14. And then I have negative 2 right here, right? So when I add all those up, I get a total of plus 6 on the left side, right? So think about 14 minus 8. Over here on the right side, the only charge is this chromium ion. It's 3 plus, and I have 2 of them. So 2 times 3 gives me plus 6. And so the charge balances as well. And so you know this is the correct answer. It balances both in terms of atoms and in terms of charge.